In this video, we are going to learn about collision theory. What is necessary for the reaction to take place? Based on the collision theory, first, the molecule must collide, but it doesn't mean they will react because the product only forms when effective collision occurs. Now, let's look at what is meant by effective collision. First, collision must be occur at the correct orientation. Let's look at this example. In order to form the product hydrogen and iodine, the reactant molecule of Hi must collide with each other in correct orientation. If the collision is successful, the molecule of product of hydrogen and iodine will be formed. However, if collision of Hi molecule does not occur in correct orientation, successful collision will not occur, the reactant Hi remain unchanged and the molecule of product of hydrogen and iodine will not be formed. Second, particle must collide with sufficient energy, which kinetic energy equal to or greater than the activation energy. What is meant by activation energy? The activation energy is minimum energy required to initiate a chemical reaction. When the molecule have sufficient energy, the reaction will occur and the product begin form. If the molecule do not have sufficient energy, the reaction cannot proceed to form the product. Before product is formed, there will be an intermediate species formed at the transition state. Based on transition state theory, unstable intermediate species called activated complex can only be formed when there is activation energy. Activated complex is temporary species formed by reactant molecule. At this state, reactant bonds are partially broken and product bonds are partially formed. After possess sufficient energy, then only the product will form. Now, we are going to learn about energy profile diagram. An energy profile diagram can be divided to two types of reaction, exothermic and endothermic. Let's consider for this reaction. If the reaction is exothermic, energy of reactant will be higher than energy of product because energy is released during the reaction. Let's look at energy profile diagram for endothermic reaction. Energy of reactant is lower than energy of product because energy is absorbed during the reaction. The peak of energy profile diagram is known as activated complex or transition state. The difference energy between reactant and product is called enthalpy of reaction, delta H. For exothermic reaction, delta is negative because heat is released, while for endothermic reaction, delta H is positive because heat is absorbed. The value of EA is measured from enthalpy reactant to activated complex. That's all for subtopic 1.2. I hope you learned something from this video. Thank you.